cylinders. Cylinders are like prisms. Cylinders are prisms that have circular bases. So they still all have two bases in a cylinder. It's not like a cone that has one base. Cylinders, two bases. One vocab word you might see from time to time is called the axis. Axis is a new vocab word for us. The axis goes from the center of the circle to the center of the other circle. So when we're talking about a right cylinder, aka it's standing straight up, it's not leaned to one side or the other, the axis is the same as the altitude, which altitude is a fancy word for saying height. Okay, we often need the height of our prism, so that's helpful for us if we know the axis. However, when we talk about oblique cylinders, which are the ones that are pushed over to the side, notice the axis still goes from the center of one circle to the center of the other circle, but the altitude is going to remain upright. Altitude and height always are perpendicular to the base. So the axis and the altitude are sometimes the same if they are in a right cylinder. But if we push that cylinder over, understand the axis and the altitude may not be the same. That's the only new vocab word we have for today. Otherwise, we're just going to go ahead and talk about the net of this figure. I like to start out with the net because I like you to be able to see where this formula is coming from. So let's talk about this. Let's draw out the net of this shape. I know I have two circular bases. I don't like that circle at all. Okay, and they each have a radius r. And then if I unfold that lateral surface on the outside, on the sides there, what shape does it make? It should make a rectangle. So we're going to draw a rectangle in the middle of these two circles. Something that we really tried to emphasize yesterday is the height of our prism. The height of our prism is always represented by the distance between the two bases, and it should always be that right angle. It should be perpendicular, which in this case it is because this is a right cylinder. So I'm going to label that height, the distance between the two bases, as h. And then I need to know the width of that rectangle. What is the width of that rectangle, do we think? If I were to wrap it back around the base, how would I find the width of that rectangle? Any ideas? The width of that rectangle is going to be represented by the circumference of one of our circles. If you think about taking that surface, that rectangle, and you wrap it all the way around here, it'll go all the way around. The perimeter of a circle, we use a fancy word for circumference. The circumference of a circle is 2 pi r. Okay, good? So we're going to come to this formula the same way that we approached our prism formula. Surface area here is going to be the area of that rectangle plus the area, of two of the circles. Oh gosh, that was awful. So how do I get the area of a rectangle? I know that the area of a rectangle is base times height. The base of this particular rectangle is my circumference. It is 2 pi r. The height of this particular rectangle is h. Plus, I have two circles. The area formula for a circle should be on your blue half sheet on the other side, pi r squared. So if I want to make it a little bit more easy to read, I can really write this all together, 2 pi r h plus 2 pi r squared. And that right there is going to be the surface area of any cylinder. Okay, you can put that on your half sheet. What's nice about this formula is that it does not need to be memorized because this is just the surface area formula for a prism. But it's a fancy prism. So as long as you remember that 2 pi r represents the perimeter of my base and pi r squared represents big B, area of the base, it's the same formula. Okay, nothing new here. We're just making them specific to circles. This is something you can memorize if you want to, but just know it's the same as a prism formula. Good? Questions? Okay. We can see it again written right here. I have it boxed in. There it is. There's the surface area of a prism. Of a cylinder formula. Okay, so let's talk the surface area of this Minute Maid can. Remember, LA stands for lateral area. Lateral area is the area of the non-base side. So in this case, it's that curved surface that goes around my cylinder. Lateral area is always, for cylinders, 2 pi r times height. In this can, the radius is 2. We have to be careful about that. Radius is half of diameter. So this is 2 pi times radius 2 times the height of my whole can, 6.5. Then I have 2 bases of this can. 2 times pi r squared. Again, that radius is 2. So there's my formula. Now, I really, really like exact values. If you don't want to answer in exact values, that's fine, as long as you are doing it correctly. You can round your answers. But I like to simplify these down to their exact values first. So 2 times 2 times 6.5 is 26 pi. And then 2 pi times 2 squared is 8 pi. So that gives me a total of 34 pi. And then if you wanted to skip all of those steps and just do approximate form, rounded form, I would take 106.8 inches squared. Either one of those is good with me. Good? Questions? Flip it over. Okay. Let's do a little bit of a word problem here for this one. A company sells oatmeal and Crisco in cylindrical containers. I don't know if you guys even know what Crisco is anymore. The diameter of the base of 6-inch high oatmeal container is 4 inches. The diameter of the base of the 4-inch high Crisco container is 6 inches. Which container has the greater surface area? What the heck? Okay, there we go. So let's draw them. The first thing is the oatmeal container. It says the diameter of the base of the 6-inch high oatmeal container. So I know that my oatmeal container is 6 inches high. Let's do that first. And then the diameter of the base of that oatmeal container is 4 inches. And then the same thing for the Crisco container. It says the diameter of the base of the 4-inch high Crisco container is 6 inches. So this one's a little bit wider and it's a little bit shorter. Okay, all good there? So now let's do lateral area, 2 bases, and get that surface area. So I'm going to fill in the little, what the heck? Did that all just disappear? Awesome. So let's just do 2 pi r squared, or pi r h times 2 pi r squared. Go ahead and set both of those up for me. You should be able to figure them out while I redraw these guys. There's my setups. Did we get those setups pretty much? Just plugging in radius and height for each one of those. I'm going to simplify each one. 2 times 2 times 6 is 24 pi. Plus 2 times 2 squared is 8 pi. So that's 32 pi, which rounds to 100.5 square inches. I'm going to do the same thing for the Crisco container. 2 times 3 times 4 is 24 pi. 2 times 3 squared is 18 pi. That gives me 42 pi, which rounds to 131.9 inches squared. So if we're asked what has the greater surface area, the Crisco container has the greatest surface area. Good. Okay, questions on that? Hopefully not too bad. We feel like this is just like plugging things in, right? We can do that? Okay, amazing. So, one super common misconception. I'm not going to make us do this entire problem, but I do want to address it to make sure that everybody's on the same page here. Let's just talk lateral area of this cylinder. Lateral area we know is the side, okay? It's that rounded surface around the outside. So that is 2 pi RH. Same formula all the time for that lateral area. When I start plugging in values here, I should see 2 pi. The radius of my circle is 6. That's not too hard. Then this is the part that people mess up all the time. The height of my prism, or of my cylinder, is the distance between the two bases. This should be a 9. What I see all of the time, because this cylinder is on its side, we always are programmed to think about height as the distance from the bottom to the top. So that would be like here, that would be a 12. But this is not 12 for the height. I'm talking about height of my prism. And height sometimes is on its side. So that happens. So I want to make sure that you understand that the height in this problem is not 12. The distance from base to base is 9. And that's what my height is. Goes base to base. And I'm pointing this out for a reason. It's because I see it all the time when we turn our cylinders on our sides. You have to be careful. Height does not always mean up and down. Okay, any questions on that one? I won't make us do the whole thing. I mean, you can. It's pretty easy. Okay, let's talk about number 3. I got a standard drinking straw. It's 19.5 centimeters long and has a diameter of 0.6 centimeters. How many square centimeters of plastic are used in one straw? Round your answer to the nearest tenth. So I need to think here. What's different about this problem as opposed to the other cylinders that I've talked about? What do I need to keep in mind when I'm figuring out how much plastic goes into this straw? Okay, oh, Dahlia? There's no bases. Those bases are holes. We can debate later whether there's 1 hole or 2 holes in a straw, but there are holes in that base, right? There are no bases in this whole cylinder. So I can just cross off this entire part of my formula. This means I'm only finding lateral area for this straw. Lateral area, once again, 2 pi r times h. I can plug all that good stuff in. 2 pi. Radius is half of diameter, so 0.3. And the height is 19.5. Maybe this is one where you're like, yeah, I'm not doing that by hand. So then you skip right to the rounded answer. That's totally fine with me. I did do it by hand. I did 11.7 pi, which makes 36.8 square centimeters. I'll take either one of those. Okay, good? One more. This is like that last problem that we did yesterday. So in this one, we are starting with our surface area, and we are finding a missing measurement. So when I am already given the surface area, the first thing that I like to do is put that surface area all the way at the end right away. I know that that surface area is 108 pi. I'm just going to leave it there on the end. My formula is the same. I'm going to write out 2 pi r times h plus 2 pi r squared. And then if I think about my cylinder, which I'm going to draw a little cylinder just for us to use here. The surface area of that cylinder is 108 pi. The height is 3 centimeters. And I don't know the radius. So I'm going to leave that as an R. So that means I cannot plug R into my formula because I don't know it. But I can plug in an H. So I'm going to plug in 2 pi R. I can plug in my H is 3 plus 2 pi R squared equals 108 pi. I'm going to multiply that 2 and the 3 together in my lateral area. And then I'm going to bring my whole formula down. Oops. Good? Anybody seeing what's about to happen here? I'm going to move everything to one side. I'm going to reorder this so it's kind of in a more standard form for me. I'm going to move the 2 pi R squared out to the front. I'm going to put the 6 pi R in the middle, and I'm going to subtract 108 pi to the other side so that I have it equal 0. Do I have a GCF in this problem? What can I take out of all three, Caitlin? 2 pi. Beautiful. Divide everything by 2 pi. That means all these pi's are going to cancel out. And I should be left with R squared plus 3R minus 54 equals 0. And this is a good old factoring problem. Factors that multiply to 54 but add up to 3. I should have R plus 9 and R minus 6 equals 0. I know I get two answers from that. That's R equals negative 9 and R equals positive 6. Can my radius be negative? No, so we know that that's not correct. My answer is radius equals 6. I got to make sure I answer all the questions, though. It wants me to find that lateral area. Lateral area is just this part of my formula. So LA equals 2 pi times my radius is 6 times my height is 3. That's 36 pi centimeters? It is in centimeters. Centimeters squared, or 113.1 centimeters squared. Any questions on that?